Hey there, this video is designed to help you with the linear applications or word problems. I'm going to go through each of the homework problems here in just a minute. However, before I do that, there's one in the mixture problems that students really struggle with the videos. So I'm going to go and do that one first. This one has to do with chocolate and its fat content. And yeah, again, you can watch the video if you'd like, but I'm going to skip right to the question. And it says a candy distributor needs to mix a 30% fat content chocolate with a 50% fat content chocolate to create 100 kilograms of a 44% fat content chocolate. How many kilograms of each kind of chocolate must they use? Now, before I get going on this, I'm going to assume that you are going to take a screenshot of this, or you're going to pause the video or something like that so that you can really study the problem. But I'm just going to kind of move on from here. I'm going to share my other camera with you. And this one is the mixture problem. Later in the semester, we'll learn a different way to do a mixture problem. This one, we can only use one variable. In the future one, we'll be using two variables. And I'm going to let x equal the amount of 30% fat content. Now, there's a total of 100 kilograms between the 50 and the 30% fat content. So here's what happens. If I have X amount of the 30%, then what's left over is going to be 100 minus X. Picture like this. Let's say 60 kilograms is the 30%. Well, left from the 100, that's going to be 100 minus 60, which is 40, right? So this is the initial amount, then the leftover is going to be the 100 minus that. This is the amount of 50%. And I'm just going to do a pseudo table here. This is chocolate. Love chocolate. And this is the amount of chocolate. So for the first one, for the 30%, the amount is X. For the 50%, the amount is 100 minus X. And the total, which is going to be 44%, is going to be, notice when I add those up, that plus that, the X's cancel, and I'm left with 100. Next up, let's talk fat. The question is, how much of this chocolate is actually fat? So let's talk fat. Well, the amount of fat that is in this here is 30% of it. And 30% converted to a decimal is 0.3 or 0.30. Now here, how much of this is actually fat? Well, it's 50%, 0.5 of that. And what's the total? Well, there's going to be 100 kilograms of chocolate. How much of that is going to end up being fat? That's going to be the 44%. And this actually, if I take the amount of fat from the 30% and I add it to the amount of fat from the 50%, I should get a total. And there is my equation. A way to do this is you could multiply through by 100 to get rid of the decimals and things like that. I'm not going to do it that way. I'm just going to do it as is and use the calculator. So this is 0.3x plus 50% of 100 is 50. And 0.44 times 100 is just 44. I'm now going to go ahead and combine up my like terms. So 0.3x minus 0.5x is negative 0.2x. Subtract the 50 to both sides. dividing by negative 0.2. Actually, what we could do is multiply the top and bottom both by 10. The negatives cancel. And this is 30 kilograms, kg. There you have it. So there's the mixture problem. I know some students tend to struggle with that, especially this beginning part with the 100 minus x, and that's understandable. All right, I'm going to switch over to the homework. Go back here, this will take a second. All right, there we go. And here we are. So this is the applications. I just did the problem here. In the homework does one kind of like this one here and these as well. So that's why I'm just going to go through the homework assignment. Only 8 questions. And I get a cool view. I get a teacher preview. You'll have to, of course, use it, meaning I can see all the questions at the same time. So let's start with number 1. It says, if the sum of 4 consecutive even integers is 244, what is the smallest of the 4 integers? Before we do that, let me switch over. Now, if I list out some numbers, and so on. If I want to start with any even integer, let's take 2, for example, you'll note to get to the next even integer, I have to add 2. Add 2. Add 2, and so on. So for this one, for number 1, I'm going to let x be the smallest even integer. Notice how I'm defining my unknowns every time. All right, now this means that the next integer, even integer, is going to be x plus 2. Right, I have to add 2 to get to the next one. Now the next one will be x plus 4, right? That's 2 more than this one. Then x plus 6 will be the largest even integer. And you can see that it says the sum. Sum in math means to add. So I'm going to take all 4 of these even integers and add them up and set them equal to 244, because it says that the sum of all 4 is 244. So here we go. X plus 2. You don't need the parentheses. I'm just really separating it out for us. X plus 4 plus x plus 6. And that should equal, I forgot the number, 244, I think. Yeah, 244. Now I'm going to combine up my like terms. X plus x plus x plus x, that's 4x. 2 plus 4 is 6. 6 plus 6 is 12. And now I have an equation to solve. So that's going to be 232. Now, if you're not allowed to use a calculator, you'll have to do long division. So in this case, x equals 58. So the smallest of these is going to be 58. Remember, that's how I defined what x is going to be. So if I were to take 58 plus 60 plus 62 plus 64, that should add up to 244. Let's see. There's 58 plus 60 plus 62 plus 64. Look at that. Pretty cool stuff. Move on to number 2. Switch it over. Now, again, the homework problems that you're going to be getting may have different numbers, but how to solve them should be exactly the same. All right, number 2. Tony is 8 years older than Crystal. In 9 years, the sum of their ages will be 54. How old is Tony now? I'm going to do this. Let you read through it. You can pause the video if you need to. That's fine. Number 2. And I'm going to let x equal Tony's age now. I like letting it be what answers the question. That way, when I'm all done and I solve for x, I'm done. I don't have any more steps to do. Now, Tony is older than Crystal, which means Crystal is 8 years younger. Now, I know in the problem it says older, and some of you were taught, like when you see older, that automatically means plus. We got to push past that. We need to actually understand the question. If Tony is older, then Crystal has to be younger, has to be 8 years younger than he is. Now, the other side of that is x plus 9 years, right? Yeah, is Tony's age in 9 years. And x minus 8 plus 9, which is x plus 1, is Crystal's age. Age in 9 years. And the problem says, in 9 years, the sum of their ages will be 54. So here's their ages in 9 years. So I have x plus 9 plus x plus 1 is going to be 54 years. There's the equation. That's always the hard part, is getting to that equation. I'm going to go ahead and combine up my like terms. X plus x is 2x. 9 plus 1 is 10. And I'm going to solve it. And I know this is Tony's age because it's right here. That's what x is. That's how we defined it. So what's Tony's age now? 22 years old. All right, let's move on to number 3. Alan needs a total of $325 to buy a new bicycle. He has $40 saved, and he earns $15 each week delivering newspapers. How many weeks will Alan have to deliver newspapers to have enough money to buy his bicycle? So I'll give you a minute to read through that again. Feel free to pause the video. I'm going to go ahead and switch back. All right, number 3. So I'm going to start out, I'm going to let x equal the number of weeks. Well, we want a total, or Alan wants a total of $325. But he only has $40. Now, I'm leaving this as an equation, even though they're clearly not equal. So I want us to view it this way. Each week, so let's say that there's no weeks. How much money does Alan have? He has $40. After 1 week, he has 40 plus $15. After 2 weeks, he has 40 plus 2 times 15. 3 weeks, 40 plus 3 times 15. X weeks, it'll be 40 plus 15 times X. And what we want to do now is solve for X. So in 19 weeks, he will have enough money to buy his bicycle. Pretty cool stuff. All right, let's move on to number 4. Two people start walking at the same time in the same direction. One person walks at 4 miles an hour, and the other person walks at 8 miles an hour. In how many hours will they be 1 mile apart? So let me adjust this while you read that. And of course, if you need to pause it, then pause it. All right, let's get a good handle on exactly what it is that we're looking at here. So here's number 4. So we have a starting point, and we have 2 people walking. One of them goes at 8 miles an hour. Another person, at the same time, same direction, is only going 4 miles an hour. They want to know how long until the distance between them is 1 mile. So they'll start out at the same position, and one is going to pull out in front of the other one faster than the other. So we have 3 components going on here. We have a rate, we have distances, and then we have a time as well. In fact, I'm going to let t equal the time. And to be clear, we are going to use a formula, rate times time is distance. All right, I like using a table for these. Oops, I didn't switch screens. I did switch screens. There we go. So I'm going to have a rate, a time, and a distance. The way I'm going to label these is I'm going to say the faster or the slower person. So the faster and the slower. We are going to use purple. So how fast does the faster person go? 8 miles an hour. The slower person is only going 4 miles an hour. The time t is what we're looking for. We don't know what that is. Now, how far does the faster person go? Well, if I use my formula and do rate times time to get distance, that's going to be 8t. So this total distance here is a distance of 8t. The distance from here to here is 4t. So what do we do with this information? Well, distance from here is 8t, and this is 4t, and I need that to equal 1 mile. So here's what I'm going to do. I'm going to go 8t, and I'm going to subtract the 4t. And that difference, that's the red here, is going to be 1. Again, this minus that gives me the red. And there's my equation. 8t minus 4t is 4t. And 4. T is going to equal 1/4 of an hour. Now, 1/4 of an hour is only 15 minutes, if we wanted to translate that. Another way to write this is you could put 0.25 hours. Now, both are correct. But this one we subtracted. The next one, I don't think we will. Let's move on to number 5. Let me show you what that looks like. Ian and Brooke are traveling towards each other from points that are 371 miles apart. If Brooke is traveling 5 miles an hour faster and they meet after 7 hours, how fast was each traveling? So I'm going to have you read through that. And again, if you need to pause the recording to read through it, I recommend with all word problems, you just read through it over and over and over again. Really get a good handle on what it is that we have. All right, I'm going to switch back. So number 5. All right, since it wants to know how fast each was traveling, I'm going to let, what are the names again? Ian. So I always ask myself, who's going faster? And it says if Brooke is traveling 5 miles an hour faster, so she's faster. So I'm going to let X equal, you can use any letter you'd like, Ian's rate. Because I know that Brooke is 5 miles an hour faster. This is Brooke. That's an R, Brooke. I'm going to set up a table again. And once again, rate times time is distance. So this would be Ian, this would be Brooke. And I already have some information about their rates. And I haven't even drawn a diagram yet. I'll get to that. So it's looking to me that we have Ian. It's going this way. And we have Brooke. That's going this way. And they are actually going to meet somewhere. It starts out, they were, this is the meet place, meet. It starts out that they are a distance of 371 miles. Now, can you see if I take the distance that Ian goes and I add that to the distance that Brooke goes, I'm going to get a total of 371. Notice neither are going 371. So 371 is definitely not going here, because Ian didn't go that far and Brooke didn't go that far. They're both going a portion of that. It says that they meet after 7 hours. Now, I'm going to use my formula. Rate times time is distance. Rate times time is distance. So to be clear, it looks like Ian goes a distance of 7x and Brooke goes a distance of 7 times x plus 5. So I'm hoping you can see that if I take Ian's distance, 7x, and I add that to Brooke's distance, the total is 371 miles. There's your equation. I'm going to apply the distributive property here. Combine up your like terms. Solve the equation. Four. Now remember, that's miles per hour. Maybe they're riding bikes or something, who knows. Now this is Ian's speed, to be clear. This is Ian. I know that because I defined x here as Ian's speed. Brooke's speed there are your two answers. This one does ask for two answers. Pretty cool stuff. Next up is number 6. All right, so we have a formula. And y equals 8mx minus 7b, and we're solving for x in this case. So I'm going to switch screens and just, oh, I did a pretty good job. This is number 6. And it says take y equals 8mx minus 7b. And we're solving for x. Well, I'm going to treat this like I would any other equation, linear equation. And I'm going to note that I'm trying to get x by itself. So I'm going to add a 7b. And I'd like to point out that y and 7b are not like terms, so they can't combine up. So again, I'm trying to get x by itself, and I have an 8 and an m being multiplied to it. So I'm going to go ahead and divide both sides by 8m. That gives me that x is equal to y plus 7b over 8m. I get students sometimes that want to get creative on me and think that they have a better way of doing it. Please don't. It'll make things much worse in some cases. There are other ways to do it, but I recommend against it. Right, next up. We're almost done. Number 7. W equals 4/7 parentheses CB plus A, and we want to solve for B. Well, let me switch it back. So for number 7, we have W equals 4/7 CB plus A. There are several ways to do this, and we can actually get a couple of different looking answers as we do this. I'm going to start up by applying the distributive property, the 4/7. It's been my experience that students tend to want to do that first. And you may be thinking to yourself, Kevin, you just made it worse. Well, I didn't. Next up, what I'm going to do is I'm going to multiply through by 7, meaning I'm going to multiply both of the sides of the equation by 7, and that's going to do this. And you may be asking yourself, why did you do that? I will show you. Now remember, that's 7/1, right? So that 7 is in the numerator. So on this side, I get 7W, no big deal. Here, the 7s reduce. Here also, they reduce. This is a nice way to get rid of fractions in an equation. Now, keep in mind, I'm solving for B. I didn't write that. Solve for B. All right, so I'm gonna do what I did before. I'm gonna isolate the B. I'm gonna subtract a 4A. And now I'm going to divide both sides by 4C, because that's what's with the B here. Now, this is again where sometimes students want to get creative. They think, ooh, 4s, and I can just knock them out. Definitely no. That is definitely wrong. When we're adding and subtracting in between, it doesn't work that way. You can only reduce things that are being multiplied and divided. So that is the final answer for number 7. And number 8, the last one. Here we are. So here's our equation. Once again, we're going to solve for x. Now this one's going to get a little tricky. Let me write it down for you. What I'm going to do with this one is I'm actually going to undistribute the x. I'm actually using the distributive property backwards. Notice if I were to distribute it back in, I'd be right back there. Now what I need to divide is all of that. There it is. I hope that was helpful for you. And when you eventually take the test, don't avoid the word problem. Try to go for it. Try to learn how to do it. Conquer this. Good luck, everybody.